Hi, this is Sir Faisal. We are doing a short lecture on types of different formulas in organic chemistry. In case of organic chemistry, we have different type of formulas. I'm taking butane as a common example in the start. Look at the formulas we normally use in organic chemistry. We have empirical formula, molecular formula, structural formula, displayed formula, skeletal formula, and journal formula, which is like a whole sequence formula. Now, what is a molecular formula? It shows the exact number of atoms of each element. So, for example, this is butane. So, what C4H10 shows? C4H10 shows that there are four carbon atoms and 10 hydrogen atoms in one molecule of butane. As compared to this, we have empirical formula. Empirical formula is basically showing the simplest ratio, like for example 4 is to 10. So when you have 4 is to 10, you can simplify 4 is to 10 as 2 is to 5, and this is called empirical formula. So empirical formula shows the simplest ratio of atoms. Now structural formula, which is very common in MCQs and short questions, it is actually showing the segments in a molecule like CH3, CH2, CH2, CH3. This is called a structural formula. Structural formula shows separate segments of carbon in a molecule. Now, look at this butane example. We have a straight chain, which is butane. Then I have shown a branched butane, in other words, you can say 2-methyl propane. This is the idea behind the structural formula. Then comes the displayed formula. What is the displayed formula? Displayed formula actually shows each and every bond in the molecule. Like butane, you can see all carbon to carbon bonds and carbon to hydrogen bonds. Look at this. This is carboxylic acid. This is ethanoic acid. And you can see double bond, single bond, all bonds I have shown. So displayed formula is showing all the bonds. Now, what is skeletal formula? Skeletal formula is, you can say, most simplified version. You can say that it's like a shortcut. So when you have to write you can say you have a carbon here, you have a carbon here, you have a carbon here, and then the free hands you have to show hydrogen. So we won't show hydrogen, we won't show carbon, and this is how we actually show the molecule. This is the skeletal formula of an alcohol which contain OH on the second carbon. This is a bit bigger size molecule, and all the points are showing, all the vertices are showing carbon, and the outsider carbons are shown. This is cyclohexane. Look at the left side. This is called the skeletal formula, and this is how we can unfold the skeletal formula. Another application is benzene. Benzene is a hexagonal ring. There are 6 carbon atoms in benzene. Carbon to carbon, there is a sequence of bonding. So benzene shows 6 carbon with 6 hydrogen. Look at this benzene, and this molecule is showing cyclohexane, cyclohexene. So this is a short introduction. I am not discussing the general term formula because general term formula is not actually specific is generalized in its term. It's used for specific homologous series, and like alkane has CnH2n plus 2, and CnH2n for alkene, which actually is used to show you can generate the whole sequence using the general term formula. Thank you.